So in the previous class, we have made ourselves familiar with the concept of heat capacity and specific heat capacity, and also the specific heat capacity of various substances. In today's class, we will move into the concept of calorimetry and what is the principle that governs calorimetry. Calorimetry, as you can see from the breakup of the word, is measurement of energy, measurement of heat energy in this case. And the basic idea is that if you bring two bodies in contact with one another, that is one hot body and one cold body, then the hot body will have higher internal energy because of the average thermal kinetic energy of its molecules being higher. Therefore, because of the contact, the energy will transfer from the hot body to the cold body. Of course, we automatically assume that these two bodies are conductors of heat. Now, the reason why this will happen is from the fact that the internal energy of the hot body is more than the internal energy of the cold body, and therefore it will transfer. And this transfer will continue to happen as long as the temperature of the hot body T1 is going to be greater than the temperature of the cold body, where T1 and T2 are the temperature of the hot body and cold body respectively. Now this transfer of energy will continue as long as there is a difference in the temperatures, there is a difference in the internal heat, internal energy of the two bodies, and it will obviously come to an equilibrium when the internal energy of the two bodies are matched. So this idea that temperature always flows from a hot body to a cold body is what is known as the principle of method of mixtures or principle of calorimetry. In your textbook, either of these two phrases have been used to describe it, sometimes asked as a 1-mark board question. What is the principle on which the calorimetry is based? What is the principle on which calorimetry is based? The answer is supposed to be principle of method of mixtures. So how does this help us to do calorimetry? So before we go into that, I'd like to talk about an example that was demonstrated in one of the previous classes of burning a peanut and attempting to find out how much energy, heat energy, does the peanut produce when it is burnt. So the strategy that I had suggested was to take a specific amount of water. Why water? Because we know that the specific heat capacity of water is exactly around, not exactly around, is around 4200 joules per kg degree Celsius. And then as you heat the water using the burning peanut, you note down the change in the temperature that is taking place. So perhaps it started off with room temperature, and then later when the entire pea was burnt, the temperature went up to a different value. So if you keep this as the initial temperature and you keep this as the final temperature, then the difference between these two temperatures, right, multiplied by the difference between these two temperatures. So if you use the equation, Q is equal to m times, sorry, 1 second. If you use the equation, Q equals mc delta T, where the amount of energy that is provided is equal to the mass of the substance multiplied by the specific heat capacity of the substance multiplied by the change in temperature. By this equation, if you know the mass of the water, the specific heat capacity of water, and the change in temperature of the water, you can find out the amount of energy that the peanut has provided. So that is how that experiment can be performed. But if you actually perform the experiment, you will find that the Q value that you get, which is the amount of energy that has been provided by the peanut, that divided by the mass of the peanut will give you the amount of energy per gram given by a peanut. That final value of the calorific content of the peanut, that is the amount of energy that is there in the peanut, will always turn out to be a little lesser than the value that has been found out and published. The reason why that is so is obvious if you think about it a little bit. The reason is because when you are performing the experiment, some amount of heat from this water is going to be lost to the surrounding. And that is the reason, that is the place where calorimetry comes in. Okay. So in calorimetry, you have to perform this experiment in a controlled environment where you can avoid the heat loss that is taking place because of three factors. One is conduction, another is convection, and a third one which is radiation. So how does calorimetry and a device called a calorimeter help us to do that? We will see in the next class.